Wiring methods for walk-in freezers and coolers must adhere to general requirements ensuring safety and compliance. All electrical wiring must comply with applicable codes and standards, such as NFPA 70, the National Electrical Code, and UL 508A, the standard for refrigerated display merchandisers. Wiring materials must be corrosion resistant to withstand a humid and cold environment within freezers and coolers. Conductors must have insulation suitable for the voltage and temperature range encountered in the specific application. Several specific wiring methods are commonly used. Firstly, mineral insulated cable, often referred to as MI cable, is approved for use in Class 1, Division 2 hazardous locations. It consists of a copper conductor enclosed in mineral insulation and a metallic sheath. This type of cable provides excellent protection against moisture, corrosion, and heat. Secondly, metallic conduit is typically used for power and control circuits. It provides mechanical protection for conductors from physical damage. Metallic conduit should be bonded and grounded to prevent electrical shock hazards. Thirdly, flexible non-metallic cord, or FNMC, is used for interconnecting equipment and appliances. It must have a corrosion-resistant outer jacket and be rated for the temperature range of the application. Fourthly, direct burial cable is designed for underground use between buildings. It consists of insulated conductors enclosed in a protective sheath and must be buried at a depth that complies with local codes. Fifthly, overhead wiring is used for lighting and power distribution in freezers and coolers. Conductors must be supported by insulated hanging brackets or clamps. Overhead wiring should be located away from equipment and moving objects to prevent damage. Additional considerations are important for safe and reliable installations. Use watertight and corrosion-resistant junction boxes to provide access to splices and connections. All electrical equipment must be properly grounded to prevent electrical shock hazards. Seal conduits where they enter or exit enclosures to prevent moisture infiltration. Regularly inspect and maintain wiring systems to ensure their integrity and safety. Specific applications and local codes will dictate which of these methods is most appropriate. Factors to consider include the ambient temperature, the presence of moisture, the potential for physical damage, and the need for flexibility. Mineral insulated cable is particularly well suited for areas where extreme temperature variations and moisture are prevalent. Its robust construction provides excellent protection against these harsh conditions. Metallic conduit offers superior mechanical protection, making it ideal for areas where wiring may be subject to physical impact or abrasion. Flexible non-metallic cord is useful for connecting equipment that requires movement or vibration. Direct burial cable is a cost-effective solution for running power to remote locations, but it must be installed in accordance with local codes and regulations. Overhead wiring is a common method for lighting and power distribution, but it must be properly supported and protected to prevent damage. Junction boxes provide a safe and convenient way to make splices and connections, and they should be selected based on their ability to withstand the environmental conditions. Grounding is essential for preventing electrical shock hazards, and all electrical equipment should be properly grounded in accordance with the National Electrical Code. Conduit seals help to prevent moisture from entering enclosures, which can cause corrosion and electrical problems. Regular inspection and maintenance are crucial for ensuring the long-term reliability and safety of wiring systems. The selection of the appropriate wiring method depends on a variety of factors, including the specific application, the environmental conditions, and the applicable codes and standards. It is important to consult with a qualified electrician to ensure that the wiring system is properly designed and installed. The National Electrical Code provides detailed requirements for wiring methods in various types of occupancies, including walk-in freezers and coolers. The code covers topics such as conductor sizing, overcurrent protection, grounding, and wiring methods. It is essential to comply with the NEC to ensure the safety of people and property. In addition to the NEC, other codes and standards may also apply to wiring systems in walk-in freezers and coolers. For example, UL 508 provides requirements for the construction and testing of industrial control panels, which are often used in refrigeration systems. The International Mechanical Code provides requirements for the design and installation of refrigeration systems, including the electrical components. It is important to be familiar with all applicable codes and standards before designing or installing a wiring system in a walk-in freezer or cooler. The design of a wiring system for a walk-in freezer or cooler should take into account the specific requirements of the application. For example, the system must be able to withstand the cold temperatures and high humidity levels that are common in these environments. The system must also be designed to prevent condensation from forming on the wiring, which can lead to corrosion and electrical problems. In addition, the system must be able to handle the electrical loads of the refrigeration equipment, lighting, and other electrical devices. The installation of a wiring system in a walk-in freezer or cooler should be performed by a qualified electrician. The electrician should be familiar with the applicable codes and standards and should have experience installing wiring systems in similar environments. The electrician should also use proper tools and equipment and should follow all safety precautions. After the wiring system is installed, it should be inspected and tested to ensure that it is working properly. The inspection should include a visual examination of the wiring, connections, and equipment. The testing should include measurements of voltage, current, and resistance. Any problems that are identified during the inspection or testing should be corrected before the system is put into operation. Regular maintenance is essential for ensuring the long-term reliability and safety of a wiring system in a walk-in freezer or cooler. The maintenance should include periodic inspections of the wiring, connections, and equipment. The maintenance should also include cleaning the wiring and equipment to remove any dirt, dust, or debris. Any problems that are identified during the maintenance should be corrected promptly. Proper wiring methods are essential for ensuring the safe and reliable operation of walk-in freezers and coolers. By following the guidelines in this narration and consulting with a qualified electrician, you can help to prevent electrical problems and ensure the safety of people and property. Remember to always prioritize safety when working with electricity. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to do the work for you. Electricity can be dangerous, and it is important to take all necessary precautions to prevent accidents. Here are some additional tips for wiring walk-in freezers and coolers. Firstly, use corrosion-resistant materials for all wiring and components. Secondly, seal all conduits and enclosures to prevent moisture infiltration. Thirdly, use proper grounding techniques to prevent electrical shock hazards. Fourthly, protect wiring from physical damage. Fifthly, use appropriate wire sizes for the electrical loads. Sixthly, label all wiring and components for easy identification. Seventhly, keep wiring neat and organized. Eighthly, inspect and maintain wiring systems regularly. Ninthly, follow all applicable codes and standards. Tenthly, consult with a qualified electrician for any questions or concerns. By following these tips, you can help to ensure that your walk-in freezer or cooler is wired safely and properly. And always remember to disconnect the power before working on any electrical equipment. This is the most important safety precaution you can take to prevent electrical shock. Be sure to test the circuit to make sure the power is off before you begin working. Use a voltage tester to verify that there is no voltage present. And never work on electrical equipment when you are wet or standing in water. Water is a good conductor of electricity, and it can increase your risk of electrical shock. Also, avoid working alone. It is always best to have someone else nearby in case of an emergency. If you do get an electrical shock, seek medical attention immediately. Electrical shock can cause serious injuries, and it is important to get treatment as soon as possible. By following these safety precautions, you can help to prevent electrical accidents and ensure your safety when working with electrical equipment.